Okay, I guess my. Okay, I'm really bad at this, so I gotta figure this out. Remove this. Um, how do I show the entire thing? Scene? Okay, I can't do that. Okay, I'm live, but I don't know how to get this to work. Let's see. Oh, wait. Okay. Oh. Add source. Okay. Okay, no. This is not what I want. Remove. Select stream. Wait. Refresh. Okay. Excellent. Perfect. That is working. Add source. Media? Okay, nope. This is not it. Delete this. Yes. How do I change this? Wait. Uh, oh. Oh, hi. I'm still trying to set up like how to share my screen. I'm pretty bad at this. So give me a moment. Yeah, I know. Like I'm trying to fix that. Like I'm very bad at this. I'm just trying to add a source that can show. Okay, maybe it's color. Let's see. Okay. Nope, color is not it. Remove. Uh, so it's my first time, like second time using OBS Studio. So maybe this screen capture. Okay, yes, perfect. Window capture. Select window. No, can I? Application capture? No. Okay, window capture. Uh, OBS Studio, OBS Studio. This is not it. I'm so sorry. Uh, Give me one moment. How to share screen in OBS Studio. Live streaming, sister. Go ahead. Sure. Display select screen in the source box. Display capture. Okay, window capture. I'll delete this. Remove. Yes. Add source. Um, uh, Claude. How do I screen share Brave on OBS Studio? So, well, till I try to fix this, we can talk. So, hi, Valu Puramshi. I'm probably butchering your name. I'm sorry about that. How are you? Okay, add source menu. Now, in your add source menu, click macOS screen capture instead of macOS audio capture. Got it? Mac. Okay, I'll just remove this. This is probably yes. macOS screen capture. Okay. Then for window, you want window capture. Window capture. Okay, is this it? Allow. Okay, wow. So that's not helping. System settings, privacy security. Shiny password. That why didn't that work? Okay. Okay. I'll remove this again. Add source, screen capture, got it. Window. Okay, nine. Empty names. Okay. Oh wait, I have to move that. Ah, I forgot. Okay, I have to move that in the same desktop, otherwise it doesn't work. Uh, this should work now. Okay, remove. Yes. Add source, macOS, screen capture. Okay, window capture, Brave live streaming. Okay, why is it cropped? Can I? Yeah. Oh god. That's a trip. Okay, let's see. Okay. Can I zoom this out? I can. Perfect. Let's see. Hmm, perfect. And I'll just zoom this. Oh, don't crop me out. Okay, how do I move this to the top? Okay, I'm learning. I'm learning. Got this. And okay. Perfect. I'll just move my screen over here. Okay, that's much better. Okay, so I cannot. Does this mess it up as well? Okay, I cannot share that if I don't have it here. So I'll move that here as well. So let's see. Oh, okay, that only shares my. That is troubling. Can I share my entire display? Let's see. Uh, macOS. Okay. Display capture, built-in retina. I should really get a mic. Okay. Is this two or one? Remove. Let's remove this. Yes. Move this to the bottom. And let's see. Does that help? Oh, perfect. Okay. So now I know what I'm supposed to do. Let's keep that there. Let's keep move this here. This. But why is that looking uh, okay, I'm pretty sure it cropped things out. Just not ideal. So we'll just fit it in the screen. Okay. I'm not happy with this, but this is the best we can do because I have like a pretty bad screen, I guess. Uh, or just let's do it like this. It's fine. Okay, perfect. I finally got this set up, so that's done. Now we can move to the questions. Can I see? I can't. Okay. Okay, there was chat. How do I see the chat? Menu, switch account, select stream. How do I see chat? Chat? No? Okay. I'll just have to toggle between this and this. Okay. So let's start with the question categorical cross entropy loss. So I pretty much did a bunch of questions. I'm pretty much done with easy, some of medium, and I'm doing them on lead GPU. Pretty great source. If you want to know like any specific place where you should go to learn, you should start with the documentation. It's pretty good documentation. So yes, how do I share pop out chat? Perfect, perfect. Okay. So in case someone joins, okay, like anyone, like hi, if you're talking in the future, it's beautiful. What does this mean? Oh wow, thank you. Let's start. Uh, so I'll just keep this. Okay, okay. Bottom. Learn more. Guard your privacy and all. How do I get rid of that? Does that get rid of it? No. Okay. Oh wait, I know something. So I can keep this. Go to view and view. Okay, I can't. I suck at it. So what I'll do instead is, sometimes things very annoying. Okay, I'm generally happy with our setup. Perfect. So I have my cloud session over here. I can bring it down as well. Yeah, in my opinion, let's do that. Sorry, like I really like to have a good setup first. It just like declutters your mind, keeps everything. I don't know how to explain it. It makes things easier in my opinion. Like if you have, God, okay, okay, uh, perfect. So let's start. Implement a GPU program to compute the categorical loss cross entropy. Okay, batch of predictions. So we have a batch of predictions. That's the logits. These are the true labels, and we have to output the loss. Perfect. N and C are probably the size of the losses. Yes, it's a matrix of size n into C, and true labels is sized n rows, C columns. Okay. Compute the average cross entropy loss over the batch. The loss for a single sample J with logits Yj is calculated using. Okay, perfect. So you have this formula of loss. So we can make a separate kernel for this. Mm, log makes sense. That is summation of E ZJK. Okay, so this I'm thinking keeping as one. The loss J can be a single kernel. So you have this summation. K ranges from 1 to C. Okay, for that specific J, okay, so that entire row. So for that row, if you want to get the loss, so like if J is equal to 0, I'll go from 0th row, like the entire thing, calculate the e to the power that, summation of that, then logarithmic of that summation subtracted by the true label. That is right, right? Uh, ZJYJ, where you started learning CUDA. Hi, Rajashika. So, where, if you want to know, like the perfect place, if you want to start out, in my opinion, is PPMP. It's okay. So wait, programming massively parallel programs. This is a great book. Where can I? Wow, okay. This is by like the team behind CUDA, so the people in what do you call NVIDIA who made CUDA itself. So this is a really good book. If it's too much for you, like you can always start out with CUDA learning documentation. So like you can just Google that, and like they have this CUDA programming guide, which is pretty good. Like it has like beginners introduction to CUDA, like the different things. Like a lot of the chapters from that book have been incorporated in this. Like they teach you the architecture, the basics. Like you start it out, and it gets much easier after that. So you can start with this, then you can start with like the easy questions of lead GPU. In my opinion, they are generally very easy questions, like vector addition. Like if you understand, okay, how does GPUs work, like you can just read like the first one, two chapters of this, then start with the easy questions. Then all of this seems like very basic stuff. So hope that answers your question. And I also have like a Claude code session on the side where I'm always like showing the question I am trying to do, what I am thinking, and it acts like my own teacher. So that helps me learn faster as well, if that makes sense. Okay, so let's try to solve this first. So first thing is you have your GPU. So let's open that. Like I genuinely love this. So yeah, architecture. Now, like these are threads. Okay, so you have multiple threads, and now you have to allocate those threads. So I'll allocate some threads in threads per block. So the number of threads you want. Now, like when you click on I, it shows you like the maximum amount of threads that you can register. So max threads per block is 1024. So I cannot exceed that. But like as you go into like some ideas like tilling and stuff, you start learning about like the exact thread count. But 256 is a good number, so I usually start with 256. And blocks per grid. So as you start reading that, you will learn that it also has mentions of blocks, grids, threads, and they are essentially hierarchy of computational things. Like uh, I, I don't know what it's called, to be honest, inside of a GPU. So let's see. Okay, so what do I want? I want L. Okay, loss is a single float, which is troubling. Um, I can keep the So like the trouble right now is I have to output a single L, and I don't want to create a temporary array. So where do we store the like loss? Like it loss will be an array, right? So if you are computing this, it will be like n cross one. Yeah, n cross one. So where do you store that? Let me think. So how many threads do we give? Each thread will take care of one row. That's what I'm thinking. So let's see. N cross 1. So n plus threads per block minus 1. Hope that answered your question, Raja Shekhar. If you have more questions, feel free to drop them in the chat. Uh, I'm not very good at it. I'm still learning. So like I can just share like what I have learned so far. Um, Threads per block. Perfect. So lost J kernel. Okay, so I'll global lost J kernel. So this is important that you always. Oh, okay, I cannot modify logits. Ah, dang. Okay, I will need to create a temporary array. Okay, so like CUDA memset, CUDA malloc and CUDA memset, got it. So logits. So it's as it says const means I cannot change it. So oh, okay, sure. I have not seen like the free code camp one. Oh, it's probably by my friend. Wait, I remember camp CUDA. Is it by Elliot? I remember there was like, yeah, it is by Elliot. Yeah, Elliot is a pretty good guy. Like, he, you can watch this one as well. Like, I have not seen it, but he's a good guy. I'm pretty sure like he has made a pretty good video on it. So yeah, yeah, you can feel free to watch that one. Like, it must be good. So Elliot, great guy, and like he does a lot of CUDA stuff. If you want, you can follow him on Twitter as well. Like, wait, Twitter, Elliot. I don't wanna butcher his name. Like, but yeah, you can look it up. Like, no, oh wow, no, no, not this. Never mind. Uh, Never mind. Yeah, so Elliot is a great guy. He has good videos on CUDA. You feel free to watch that. Uh, Wait, is my live stream saved? I don't know. Let's see. True labels float. Yeah, I don't know. I don't know. Ah, okay. Float star loss array. Because the way I'm thinking is like, and see, it'll make more sense in a while if it's not making sense right now. So, um, float star. How do you assign memory? Loss array. CUDA. I know it's CUDA malloc. What was? Is it? Okay, so I know I have to do this. I have to do CUDA mem set. So these two things I need to do. I do not remember the exact documentation, if that makes sense. So I'll just look it up. And I'll initialize the kernel. Mm, let's see. So I am giving logits. So like that is the input. True labels, because we want to do the thingy, right? Like the subtraction. So loss array. So this will not compile at the moment because again I really forgot the documentation. So that is one problem with like using Cloud or anything, like you forget things, right? And gid is equal to thread idx dot x plus block dim dot x multiplied. Again, like if this does not make sense, like this is pretty rudimentary. I'm just like getting the global ID of each thread, and it's a really helpful mental model to imagine like your final output and thread ID. So like what will each thread be doing? Now I'm pretty sure this can be parallelized better, but I'm separating this out. So this would be done by like n threads, and like then a single thread will compact all of that. So it will take loss array. Oh wait, I have to do CUDA free as well in the end. So I'll have um, so I can make another global uh, void. Wait, I'll just go turn my camera off for a moment. Yes, perfect. Okay, let's start again. Uh, so global void cross entropy loss. Now what this would take would be the array. So that would be loss array and float loss, and put the final float loss. So perfect. Float star loss array. Float star loss, and int n, and in C. Well, not really. C is not required. Yeah, C is not required. At least I think it's not required. So let's see. Oh wait. Oh my God. What do? Never mind. That's stupid. Oh, wait, I'll need to initialize another. Okay, for block and thread because of another kernel, so that will be waste. So sorry if my words sound like rambling, but if you have questions, feel free to drop them in the chat. I'll try to answer them as best to my abilities as that I can. So in threads, oh, that is fine. Blocks per grid. I don't. Wait, what if n is greater? Oh yeah, yeah. So what? A single thread is doing it, right? Yeah, single thread. Okay, fine. It does not really matter because like cross entropy loss, which is again like not the best way to do it, but I know I'm just gonna use atomic add. Like again, don't use atomic add if you know what atomic add is, great. It is a shortcut, honestly, and I'm still learning. That's why I'm using it. But the best way is using reduction way. So like, do parallel reduction. Learn better, do better than I do. Okay, so let's go. Mm, uh, Cross entropy loss, perfect. So this would take loss array, the one that we initialized. This would take loss, and this should take n. Perfect. So So now you have to have a condition that GID must be less than n. Otherwise, you have issues. Okay, like bunch of issues. Okay, now we do the thingy. Okay, what do I do? Atomic loss of logits. Wow, I really do not like this solution, but I know it will work. So let's try with this. Float temp is equal to 0. Does that cause any problem? I don't know. For int I equal to 0, I less than c, I plus plus, temp is equal to zj, right? Row column. Okay, so that would be logits gid and I plus. So now I do not remember. Okay, what is to the power e? It's probably, what is ex? But I should hide this, right? Hide top sides. Um, Damn. Exp, expf, CUDA. So, difference is time string device. Okay, hardware accelerated. So that's what we need. See, I told you, I have like kinda remember these things, but again, okay. So that takes care of this part. Now you still need to take the log, so that's what we'll do. And wow, I don't remember what the log one is, so let's just look up log. Uh, Log CUDA log f. Yeah, it's probably log f. You can use. Let's use this one. Yeah, just because of continuity's sake. That makes sense. Let's see. So temp, again, this could be much, like, because it's one kernel doing like this, so it's much better to write a parallel reduction loop. Like, you can write like just one reduction kernel, and you can call a kernel inside a kernel, right? Yes, I think you can do that. So yeah, and you can just call that inside of this, and that's much better because this is one kernel doing this entire operation, which is bad. Okay, like it's genuinely bad, and you don't want to do that. So, like, if you're a good CUDA programmer, you don't want to do that. If you're not, the world's your oyster, bro. GID is equal to, let's see. So I have log. Now I just need to subtract. What is JYJ? That's two labels, right? Why is it? Yeah, it's fine. Yeah, it's fine. It's fine. It's fine. Let's see. Temp minus. Do I need to do absolute? No. So true labels. Oh wait. Yeah, I can turn my camera back on. So yeah. Yes. Hi. Sorry about that. Let's see. Uh, True labels. Now I can put GID here, right? Yeah, GID. Mm, and that takes care of that. As companies working on their own chips, do you really think? Oh, that's a great question. So, like, my opinion on that matter is that CUDA does not restrict you to NVIDIA. Like, CUDA really teaches you to think about how GPUs work. Now, if you understand how GPUs work, you can just translate this information to any other GPU chip. Like, even if you're making your own chip, you understand, okay, what are threads and like how does computation work. So it really helps. Like, if I want to code this in AMD, I can do that. Like, AMD has an open source CUDA alternative like that they use for AMD chips. Like, wait, AMD CUDA alternative. So I'm pretty sure like the document, yeah, it's ROCM. Yes, ROCM. So, like, I believe they have the GitHub as well. Yeah. So this is completely open source, and like it is much or less exactly like CUDA. You just have to understand how GPUs work. So like this GPU architecture is usually like the same no matter what kind of chip you're working with. Like, they just change the location, they change few ideas. But if you understand, okay, what a DRAM is, what L2 cache is, what is shared memory, what are registers, what are threads, you can use them on any chip. So if you get it, the way I like to think about it is like, if you're really good with PyTorch, you're you can be good with TensorFlow as well. You can be good with scikit-learn and all of that. So it's just levels of things. Like, if you're really good at understanding how the GPU works, you can use it with any chip architecture, in my opinion. At least that's my opinion on the matter. Like, I haven't gone through ROCM for AMD, but like BLAS, like that is basic linear. Wait, so BLAS, CUDA, what does it stand for? It's linear algebra something. Yeah, basic linear algebra subroutines. So everyone writes BLAS no matter what their chip is. So if you understand how BLAS works, what is vector multiplication, matrix vector multiplication, it does not matter what chip you're using. Like, you'll always understand like the underlying GPU architecture. And if you want to get better at that, there is this GPU glossary that I genuinely love, and it just, like, this is how GPUs are made. This is how GPUs work. Like the hardware and all that. Like, what are cores? Like, what does a tensor core mean? What does a CUDA core mean? If you want to make your own GPU, how do you do that? So understanding all of that is very helpful. Like, okay, what is int 32? What is float 32? What is float 64? Why does it make a difference? What is a warp scheduler? So no matter what chip you are using, it's always useful, in my opinion. Like, if you really understand how JavaScript works, I'm pretty sure like that also translates, right? Like, if you know C, you can learn C++. You know C++, you can learn Rust. So it's not a big problem, in my opinion. It's always great. So yeah, like, I think it's a worthwhile investment to learn CUDA. That's my take on it. So let's see. Again, I might be wrong, but it is a genuinely tough thing, and it's very fun to try and solve it. Okay, now this would be a single kernel, and yeah. Uh, oh wait, I can just do atomic add here, right? Yeah, okay, wait. Atomic add, uh, and temp. So atomic add is magic. You can look it up. Like it's very hard to find CUDA documentation for some reason. So CUDA documentation, like I can just search this up and like it won't show up. Yeah, see, like math works. Like UNE, VDA It's so hard to find NVIDIA documentation on things. Yeah, even this is not exactly the documentation. Like it's just a programming guide. So now I have to go to atomic add, and yeah, it's much better to ask like Claude about it in my opinion. So yeah, like it takes an address, the value that needs to be incremented. But it serializes the threads, so it's not good. But I'm lazy, so we are using this for now. Okay, let's see. So now I just need the loss, and loss would be atomic add. Okay, wait. I can just write this, right? Yeah. Atomic add. Uh, is that an address? Yeah, that's an address. Loss. Oh wait. Okay, wait. This might be wrong. Might be wrong. Might be wrong. Okay, this might be wrong, so I'll just keep this less than n. Or let's see. No, columns. Okay, columns. I plus plus. Uh, Again, if none of this makes sense, feel free to ask me. Like this took me months to understand. uh, temp is equal to plus equal to logits expf logits gid I. Now I'll just comment this out because I'm not exactly sure if I can do atomic add like this. Um, Mostly because I do not remember divide equal to n. Okay. Now there would be a thousands of errors and problems in this, so we'll just give it to Claude and it will help us out figure them out. So we also do CUDA free loss array. It's very important to always free the memory, otherwise it's always occupied. So don't forget these semicolons. I always do. So let's see. First you give the problem. I am trying to solve this problem. This is my solution so far. Am I on the right track? Is the atomic add correct, or do I just... Oh wait, is it... Okay, it's thread, right? Okay, atomic add might be wrong. Yeah. Or do I just add it using a loop? Now Claude will think and give us info. Meanwhile, I'll just create ls cd medium. So I'm keeping track of these questions as well. And like in case someone ever needs them, they can always look up my solutions in GitHub. So when let's see. Okay, you're on the right track with two kernel approach, but there are a few conceptual issues. There always is. For the no atomic address between thread. Yeah, makes sense. So per thread restaurant is correct here. Okay. What should be the index? Yeah, perfect. I knew it. So so this would be wrong. Equal to 0, I less than n. Again, this is not great. I don't like it, but I don't really want to write a indexing loop. Wait, logits? It's 1D? Oh, it's 1D. Dang, okay. I need to fix that. Okay, it's 1D, so it's not 2D. It's a bunch of things. So I will go one by one. We'll first fix the loss is equal plus equal to loss array I. Now this is correct. Now that's a problem. So we need to get the. Okay, I've done this before, so I'll just C plus I. Now if that does not make sense, divided by C. Okay, so first that gets the row. Oh no, damn. Okay, so it's supposed to be 0th row, GID. Okay, it's not multiplied, it's multiplied. Okay, now this is perfect. This is correct. Okay. If that doesn't make sense, so each thread computes each row. So 0th thread is supposed to compute 0th row. Now, when GID is equal to 1, that is supposed to go to second row. Second row is when like you cross all the columns. So that's like multiplied by C. And as for resolving the race conditions, so minus logits. Loss. Oh, do I need to do sync thread? I need to do sync threads, right? Wait, no, that is synced internally. Oh, wait. Ah, okay, I get it. Okay, that is an index. I didn't realize. True label. So that is the correct index for that row. So that is GID times. So pick the row and then the true label on the row. That makes sense. Okay, loss is a pointer. One comma one. What about now? Okay. Still an array of float pointers. You want a single pointer to a device memory. How many? Okay, as I said, I forgot what I forgot the argue CUDA malloc set take. Please help me. Okay. Okay, so I read about why you need to do this, but I forgot. Float size of float times n. Oh, okay. Array, comma 0, comma n times size of float. Okay, that makes. Okay, cool. That makes sense. Um, okay. Mm, guess I'll need to stop after a while, but yeah, this looks fairly right to me. This takes a white star. So, what about now? I feel like this is wrong. I've done it before and I usually just give the address. What's that? Okay. Type names from document, don't write them. Ah, okay. Ah, makes sense. I knew it, told you. So, oh, it's from. Okay, it takes pointer. That takes pointer to a pointer. Ah, got it. Yeah, it did pretty good. Okay, okay. Now let's run it and see. I'm not very happy with it again because I can add a reduction loop here and here, like two reduction loops. Let's see. If it works, I'll be very happy. Sure, bro. Feel free to do that. Um, Anything that let's improve this, right? Uh, Work, work, work. Please work. Um, Again, this was a relatively simple problem. Uh, Perfect. So, thank you for joining in, guys. I had fun. That was a fun question to solve. Thank you to the 13 viewers. Yeah. See you in the next one. Bye bye. Not be able to your stream when you'll now.